Hello, chemistry students. This is going to be the first video lecture that you guys are going to watch for me. But before we start, I just want to make extra sure that everybody is on the same page with what they are supposed to be doing. This is the presentation I'm going to talk through with you guys right now. While you're watching this video, your job is to be on this sheet, this note sheet. You should have already made a copy of this, and your job while I'm going through the presentation is to fill in these blanks. Now in the presentation, these blanks will be filled in and you'll be able to go along with me as I go. So let's go ahead and get started. We're going to talk about what even is chemistry today. Now before we start, I want to go over our learning intentions and our success criteria. By the end of this lecture, you should understand what chemistry is and how it applies to the world around you. And how will you know that you've done that? Well, first, you'll be able to explain the characteristics of matter and what substances are. Second, you'll know the difference between mass and weight. And third, you will be able to name and explain what multiple branches of chemistry are. A couple other things that I'd like to talk about before we dive too deep into chemistry are our science standards that we are following along with in my class. So there's a few things to understand about the science standards, and those are DCIs, SEPs, and CCCs. DCIs are disciplinary core ideas. So fundamental ideas that are necessary for understanding any given science discipline. SEPs are science and engineering practices, and those are behaviors that scientists engage in as they investigate and they build models and theories about the world around them. Cross-cutting concepts are concepts that are going to bridge disciplinary core boundaries, bridging different subjects together. So practices or concepts or whatever that apply to multiple different branches of science and engineering and even math. All right, so let's get started with our actual content. What is chemistry? Chemistry is the study of matter and the changes that it undergoes. But to really understand what I mean by that, you have to understand what matter is in the first place. Matter is anything that has mass and takes up space. So you are made of matter. The pen on my desk is made of matter, air is made of matter, water is made of matter. And quite frankly, I'm assuming that you've heard this definition before, assuming that you've been to a middle school before. They would have all defined this for you at one point. But chemistry is, in and of itself, based on that definition, the study of everything that happens to be around us, everything on Earth, everything in the foreseeable universe. So, next thing to define, what is a substance? A substance is a chemical defined as matter that has a definite and uniform composition. So a substance, again, could be pretty much anything that is made of matter. So again, anything that you see around you is a substance. So ozone is a specific example of a substance. You can't see it, but you know that it's there. What do we know about ozone? Well, we know a few things about ozone. It protects the planet Earth. Ozone, for those of you that don't know, is O3, or it is made up of 3 oxygen molecules. Now that's not 3 oxygen molecules total. Every molecule of ozone is 3 oxygen atoms stuck right together. So what that functions to do, it's actually really helpful for the planet. It traps heat here. If we didn't have one of those, one, we would get beamed by super harmful radiation from the sun, and 2, heat would not be as trapped close to the planet. So we would have much harsher climates on planet Earth. The days would be much hotter, the nights would be much, much colder, because the ozone layer serves partially to insulate the planet, which is very nice for us. Okay, so characteristics of matter. Some matter occurs naturally, which means that you can find it naturally on the planet. It wasn't man-made. So ozone is one of those things. It's there not because we put it there, but it's there just because it is. And some matter does not occur naturally, like the CFCs, the chlorofluorocarbons, that are manufactured by man because of chemical processes that we do in factories and cars and just a bunch of things. So we are putting unnatural matter into the atmosphere, onto the planet, and that is a problem. Mass, another thing I would like to talk about, is the amount of matter that you have. Very different from weight, by the way. The difference between mass and weight is that mass is the amount of matter that you have, and that it does not change location to location. So the easiest way to define this is saying you're going to have the same amount of mass on Earth that you have on the moon. But if you were to measure your weight on the moon, that would be much different. Weight is the amount of matter as well as the amount of gravitational pull on that matter. So the moon, being much smaller than planet Earth, has less gravitational pull on you, were you to go to the moon, which means that you would weigh less on the moon than you do here. But that doesn't mean any of your mass has disappeared. It just means that your mass in relation to the moon is different than your mass in relation to planet Earth. So it's very important that you understand the distinction between those two things, because we're going to always talk in terms of mass in this classroom. We will rarely, if ever, talk about matter in terms of weight. All right. Another thing that I forgot to mention is that in higher altitudes, your weight will also change. As you get farther from the planet Earth, your weight will become less because Earth has less strong gravitational pull on you. So that's pretty cool. Next, we're going to talk about some branches of chemistry. There are a bajillion different branches of chemistry that you could talk about. There's a bajillion different jobs in the different branches of chemistry that I could talk about right now. Here's some of the main ones. We've got organic chemistry, inorganic chemistry, physical, analytical, biochem, industrial chem, polymer chem, and thermochem. So to define those as we go, organic chemistry is chemistry that deals with molecules that contain carbon. That's what organic means. So if you've ever walked into a supermarket and seen a product that says, hey, this is an organic product, that is completely different than what I am talking about here. Scientifically, to be organic, something has to contain carbon. So every food that you've ever consumed has been organic in terms of science, because every food you've ever consumed has carbon in it. All right, so examples of the types of things that one might study if you were an organic chemist would be pharmaceuticals and plastics. Any drug, be it Tylenol or phenobarbital or anything that you would put in your body that has an action on your body, has carbon in those molecules, any drug whatsoever. And plastics also contain carbon as well. So they would fall under that umbrella of organic chemistry. Inorganic chemistry, on the other hand, deals with matter that does not contain carbon. So examples of that would be minerals that are not carbon-based, metals, non-metals, anything that's a semiconductor that just doesn't contain carbon would be examples of something that one would study if they were an inorganic chemist. Physical chemistry deals with the behavior and changes of matter related to energy changes. So physical chemistry actually can deal with a lot of different things. So you could be a physical chemist studying chemical reactions that are organic, or you could be a physical chemist studying reactions that are inorganic. So that you see a little bit of crossover there, but with physical chemistry, you're focusing on reaction rates and you're focusing on mechanisms of reaction, which involves electron movement, and it involves studying the exact way things are reacting with each other and all the side reactions it can produce, et cetera, et cetera, et cetera. Analytical chemistry is going to focus more on the components and composition of substances. So again, you could be studying a substance that's organic, or you could be studying a substance that's inorganic. It doesn't really matter, but you're looking at what's in certain things. So an example that I could bring up, somebody who's studying food nutrition or is a quality control expert or a forensic scientist or something, is going to look very, very closely at the components within certain things. Like, for instance, a crime scene or a food item or a new drug or anything really. Biochemistry studies matter and processes of living organisms. So living organisms contain carbon. So again, you have your organic chemistry component of biochemistry. But biochemists look at processes more than just individual chemicals. So they might study your metabolism, or they might study fermentation, or they might study the effect of a new drug on somebody's whatever process in their body. So biochemists are, again, more focused on people, animals, and their processes. Environmental chemistry is going to study matter in the environment. So once again, if you are alive, you contain carbon. So there is an organic chemistry element to that. There's an inorganic chemistry element to that too, because the environment contains the water cycle. The water doesn't contain carbon, so that's inorganic. So what they are looking at is mostly things like pollution, and they're looking at biochemical cycles of entire ecosystems and what factors can affect those cycles and how to keep the environment functioning with peak efficiency, or a bunch of different things, but as related to ecosystems as a whole. We have industrial chemistry, which is going to focus on chemical processes in specific industries. So like paints or coatings or stringent materials that one might use for engineering, for building things. Anything like that is going to fall under the umbrella of industrial chemistry. We have polymer chemistry, which is not super different from organic chemistry, because polymers, huge chain molecules, are often carbon-based. And I'll get into why huge chain molecules are usually carbon-based later in the class, but generally they are. And again, plastics contain carbon, so that's going to be studied in polymer chemistry. But their focus is more on textiles or coatings or plastics than it is just any type of organic molecule in general. And then thermochem. Thermochem focuses on the heat involved in chemical processes, and in relation to heat, the energy involved in chemical processes. So they're going to look at the heat or energy of certain reactions, how to make reactions more efficient, maybe adding catalysts or not adding catalysts, or just how those reactions interact with the surroundings of that reaction. So a lot of reactions will emit a lot of heat, or maybe the exact opposite happens, that reaction absorbs heat. So thermochemists are going to look at that. When I see you in class, we're going to do a discussion post about different types of chemistry, but until that time, I just want you to stop here, and I will see you in class.